micro nano education for everyone.
Good morning, everyone. I'm so glad you could all join us here today for this workshop on how to explore any data set in pandas with using Python. And our presenter is Trinity Chung. She's an experienced Python coder and tutor who has 3 years of experience teaching code to students of all backgrounds, from elementary through college. She's also worked professionally as a software engineer intern at JPL, Caltech, L3 Harris, and has done other freelance work. Trinity is currently a rising senior at UC Berkeley studying computer science, and she's involved with Berkeley's Open Computing Facility, or OCF, and the Berkeley Laboratory for Usable and Experimental Security, called BLUES. So Trinity, looking forward to your workshop. Thank you so much.
Hi, hello everyone. Thank you for the introduction, Tanya. So just let's do a quick introduction on who uses pandas. So if you are aspiring scientists, engineers, statisticians, or you just want to look at some data, pandas is a really good tool to use. It's essentially a library or a bunch of other code that other people wrote, which you can use as a tool to help you kind of, like load in and explore and even visualize your data. So it's built on top of Python. And so our little plan for today is we'll do a quick Python review, and then we'll go right into pandas and how to load in your data, how to take a look at it, and of course, cleaning your data so that we can visualize it. So we're going to open NanoHub. So NanoHub is kind of the tool we use a lot at MinKern. But you don't have to be a MinKern member to use it. You can go to this link. And first you want to make sure to have an account. And if you already have an account, you can go ahead and log in. If you do not, you can go ahead and sign up. I'm already logged in here, so I'm going to go to my dashboard. Okay. Looks like most people are here. So in your NanoHub dashboard, we're going to use what's called Jupyter Notebook, which is kind of an environment for Python. I already have a session open, but if you do not, you would go under My Tools. You can look at All Tools and look for Jupyter Notebook. And there are multiple versions of Jupyter Notebook. Please use the most recent one, which I believe is this 2021-05. So if you click this little square button, it will launch that notebook. Okay, once you open Jupyter Notebook, you should see, well, you will have different files than I do, but you should see some files. And let's start fresh and open up a brand new notebook. So there's a new button near the top right corner. There are many different versions of Python. We'll just go with like the default Python 3.8. Okay, so I'm hoping that most of you are already a bit familiar with the Jupyter environment, but if not, that's fine. So Jupyter works in little, I guess, like chunks of code. So this first little box you see we'll call a cell, and you can type in here any Python code. So like x equals 3 plus 3. Right, and in order to run the code, you can click the run button. A shortcut that I will use often is just pressing Shift Enter, and then that will execute this line. And right now, if I want to see my results, I want to see what X is, then I can type X and a new line, and it'll show me the output 6. And so remember that in Python, well, I just declared a variable in Python. In order to make a variable, you just do like the name of your variable, in this case, x, equals, and then on the right-hand side of the equal sign, some value. And we can work with numbers. We can also have decimal numbers. We can have Boolean values, which are either like true and false. We can have text, or they're called strings because they're like a string of characters. So you can do text. If you put it in either double quotes or single quotes is fine. And what else? We have numbers, and we also have lists, which are sequences of things. So list, we use square brackets. And inside of lists, you can put whatever data type you want. And we also have dictionaries, which look kind of like this, where instead of having, in a list, you just have like a bunch of stuff in it. I guess like, let's say this is, I'm going to make a variable called shopping list. And then let's say we're buying like apples and bananas and I don't know, some bread. Right, so when we have a list of things, we can use this. A dictionary also contains like multiple things, but instead we have them in pairs. So let's say I have a student here, and their name is Bob, and their favorite subject is computer science. So we can store information and organize it in these different ways. So I guess for my shopping list, I can access list elements by their index, starting at 0. So apples, it's the first thing in my list, but since indexes start at 0, this would actually be my 0th element. I can access it using my variable shopping list, bracket 0. And I'm going to print this out so that when I run my code, I can see the result of printing shopping list bracket 0 gives me apples. And then for a dictionary, for my student, if I want to know what my student's name is, instead of using a number representing like the first or the second or third, I would use the key that is associated with his actual name. So I'm looking for the student's name, and if I print this out, it tells me his name is Bob. Okay, so that was just very quick review on Python data types. We're going to be using things that are similar to lists and dictionaries and pandas. So I wanted to go over that real quick.
Trinity, I'm often confused about dictionaries, but maybe it'll become more apparent when we see more examples of how those work. Like if you had more, I don't know exactly what my confusion is, but lists seem more straightforward.
Yes, yeah. Lists, you just have a bunch of things separated by commas. Yeah, for dictionaries, because we have this, we have a bunch of pairs of things. Okay. Yeah, so we always have pairs of things that are separated by colons. And then each pair of things is separated by a comma.
So right there, if you had another student who has a different favorite subject, how would you add that in? Maybe that would help me understand.
Sure, we can make another dictionary. So let's say this student is student 1, and then I'm going to make a copy of this and have another student 2 whose name is something else and whose favorite subject is also something else. So I can access everything in the same way. I can print my student 2's name. And even though this looks very similar, I'm printing their names because the value associated with the key name is different. It'll show me Bob and then Alice. Okay. All right, so that was our crash course on Python. And it looks like in the chat people see good or it's clear. Okay, let's move on to pandas, what we're all here for. So in order to use pandas, remember, it's a bunch of code that other people wrote. So it doesn't come with Python by default. Therefore, we are going to import it in order to include it in our project. So you import pandas. And if we run this code, it'll seem like not much has happened. Let me know if you get an error. I believe the Python in like NanoHub's Jupyter Notebook includes pandas. Okay, well, once we have pandas, now we can actually use the variable pandas. And you see, this is a module. This is where, it's a file somewhere, right? Again, it's code that other people wrote. So you see, this is actually a pandas init.py file. And so it's like a big Python file that other people wrote. And now we can use this module. It comes with a lot of handy functions and data, special data types, which we're going to use. Okay, first things, let's grab a data set from somewhere and use it. If you have your own data set, as anything you're interested in, I don't know, a list of all the different kinds of bugs living in the Amazon and their associated heights and the colors and whatnot. Or this can be like a data set of all the stars in the sky. It could be a data set of, students in your classroom. It could be anything. But yes, I have one which I'm going to use today, which let me find the link. I just put it away somewhere. This data set in particular is from NASA's open data set. And then I'll also open it in a new tab here. All right, so this is NASA's open data portal. And this is a data set about meteorite landings. If you like, you can explore the data catalog. They have lots of interesting things. Or if you want to use, if you are interested in looking at all the data they have a lot available in their data catalog. This one in particular I chose. It was arbitrary, but if you want to follow along with this one in particular, which again, you don't have to for this. If you're feeling a bit more brave, you can try using a different data set. But if you want to follow along, you can use the same one. I'm going to first download this data by clicking export. And I'm going to download a CSV file. So a CSV file is actually comma separated values. I can actually open the CSV file directly and look at it. Yeah, so I just opened the CSV file, and since I'm on a Mac, it opened it with using the Numbers app. So it has it formatted very nicely. You can see all the data. We can also just view the text file directly, which give me a second to open that. So if I open this using a text edit application, this is what is actually inside of the CSV file. So it's not formatted nicely at all. It's just a big blob. Again, CSV stands for comma separated values. So if you see this very first line is all the names of the columns separated by commas. And then each line after that is all the values that are all separated by commas. But this is a very common data format that people use. And it is one of the data formats that pandas can recognize. So once you have downloaded that to your computer, we need to actually upload this into our Jupyter environment. So on the top left of Jupyter, I got a question in the chat. Make sure you download the CSV file. Although I think it probably still would work with the CSV for Excel, but just to be safe, download the regular CSV file. Okay, so if you open, go back to your Jupyter notebook, and if you go to File and Open, it's gonna kind of open a new tab and take you back to this page. In order to upload our data file, we're gonna go to Upload, and then you want to find your CSV file that you just downloaded, and then click Open. So, and I already have it loaded in here, so I'm gonna delete it, and I'm gonna upload it again. Okay, yeah, and there should be like an upload button. You will have to click that in order for that to actually get uploaded. It might take a couple seconds. Once it's done, it should show up alongside everything else. And then we can go back to our notebook. Now you can check whether you've done that correctly by, we're going to load in the data. Let's say our, we'll call our meteorites. We're going to use pandas, and they have a nice function called load CSV. And then we're going to use a string, so double quotes or single quotes, and the name of our file, which was meteorites, meteorite landings.csv. So I'm going to type it exactly the way I have it in my file, meteorite_landings.csv. And then on a new line, because I want to actually see what my meteorites looks like, and type it on a new line. I'm gonna hit run. Oh, okay. I misremembered the name of the function. It's not load CSV, it's called read CSV. There we go. So let's get going. So looking at our data set, we have these columns. We have this very first column is just, it seems to just be counting up in order from 0 all the way to this number. We see the dot, dot, dot in the middle. So this means like this is like the very, very last few rows of the entire data set. And in total, we have 45,716 rows in this data set. So that's a lot of meteorites. And then we have all the different ones. We have name, which it seems to be alphabetical. We've got an ID. So notice how the IDs are not necessarily in order. If I would like to, you could click on ID And I think it would order the table based on that. No, I don't think it's doing it correctly though. So it's because it's only ordering the ones that we can see right now. Yeah, because like we're not looking at all the data or we're not looking at all 45,000 rows. We're only looking at a small subset of them. Okay, so I just ran my cell again in order to like put it back to how it was. Yeah, so we have all this stuff. Now, what do I want to know about this data? I would like try to formulate a question about your data set. And let's try to investigate and find the answer. So maybe for this particular data set, I'm interested in when were the biggest meteorite landings? Like what were the names and times and places of the largest meteorite landings? So you can see this one, like Abby, is that's pretty big, right? This some of the other ones are only like a couple of grams, but this one's like 107,000 grams, so much bigger. So let's say we're only interested in the mass G of my meteorites data set. I can access columns by using my data is loaded inside the meteorites variable. And then kind of like a dictionary, I can use the name of my column, which is mass G, has to be exact. And this gives me a sequence from 0 all the way to that 45,000 of all of just the masses of the meteorites. All right, so if I'm curious, what is maybe like the biggest one out of these? I think we can do dot max. Yep. We can do dot max. And then from my column, right, my mass G is my column. As you saw before, it was like a sequence of numbers, every single mass that we have. And I see that the max one is, now this is 1, 2, 3, 4, 5, 6. I count right. Yeah, that's like 60 million. Wait, the 3, the 4, 5, 6. Yeah, 60 million grams. So that's a really big meteorite. And then now, if I wanted to get the name and everything else associated with this, well, we're gonna have to like clean it up a bit, since I'm not interested in this ID column, nor am I interested in this like name type or red class. So let's try to clean up the data so that we can find the row where it's just has the relevant information that we want. So I want to find in my meteorites data set. First, I'm going to delete some of the columns that I'm not interested in, because there's a lot to look at. So what we can do is you can use drop, and then we can drop or delete the columns we don't want. So if I try drop name type, for example, and I run this code, drop, I believe we have to set the axis Okay. So drop can be applied either on the rows, so we can like drop certain rows, or we can drop certain columns. The axis equals 1 is telling it that we are using columns. So axis equals 0 by default. I'm just leaving a little note here. This is in Python, you can make comments using the little, what do people call it? Pound symbol, hashtag symbol, waffle, whatever you want to call it. Axis 0 is by default, which refers to rows. And then we want to drop a column. So we set axis equal to 1. Yeah. A lot of pandas functions have this sort of thing where they can apply either to the rows or the columns. So we might see this axis thing come up later too. Okay, so I dropped name type, so now you don't see name type here. If I want to drop multiple columns, I can change this from just right now it's just a string, but if I want to do multiple, I'm going to put it into a list. So I put the square brackets around it. And since I have the square brackets around it, this is now a list. So I can now do comma and then have all the other ones I want to drop in here. I want to get rid of like the ID. I get rid of the fall. Let's also, if I look at these two columns, the rec lat and rec long, as well as the geolocation, actually notice that they have the same information in them. It's just that geolocation, it kind of has both the latitude and the longitude combined together. Since it's kind of redundant, I'm also going to drop geolocation. What else did I miss? Oh, I want to drop rec class as well. Okay. If I do that and I run the code, you can see I have a much less columns, more of just the ones that I'm interested in. And then finally, I want to save this new data frame. So this, when we call any function on our data set or in pandas, we call this data frame. Yeah, we can actually check the type of our variable meteorites and tells us it's a pandas data frame. So again, remember, pandas is a bunch of code that we didn't write. So borrowed from other people. And we have from Python our default data types, which are like numbers, booleans, strings. You can actually make your custom data types. And data frame is a special custom data type that kind of represents what we just saw, which is like our table that contains all of our data in it. Yeah, so meteorites is a data frame. When we call the drop function, it actually doesn't change the original data frame. So I call meteorites.drop, but if I look at meteorites again, oh, it still has everything. So if I want to save the cleaned version where I dropped everything, I would have to put that in a new variable. So I could do cleaned meteorites equals the result of doing drops or drop on the original meteorites data frame. Now, if I look at cleaned meteorites, now this is the version of the data frame where we have dropped everything. Okay. So we have kind of cleaned up our data, so we have just the information that we're interested in. And then I want to find the row where I have the biggest meteorite. There's a couple ways I could do this. Since we figured out earlier that the maximum mass in the meteorite's mass column is this number, we can use the where function in order to find where the mass is equal to this number. So on our clean meteorites, we do dot where, and I'm going to pull up the pandas documentation for the where function. Okay, so I just Googled like pandas where, and then it will load the documentation. There you go. It will load the documentation page. All right, I just Googled it online, like pandas where, and then this is the pandas website where they have all the documentation and like helpful information about all the different functions and things that are part of, that comes with the pandas library. Okay, so when you are working with pandas on your own, I mean, we'll only get to cover like a very small subset of what you can do with pandas in this workshop. So chances are, if you're out there exploring on your own, you'll want to refer to the pandas documentation in order to know exactly how to use this function. So yeah, if I'm coming across this the first time, I would take a look. I know it looks kind of scary because there's all these different like options and oh my goodness. Right, it looks like the main thing here is cond, which is the condition. So first parameter when I call where is cond, it says it should be like a Boolean, it should be a Boolean series, or it should be like array-like or callable. Okay, that doesn't make too much sense to me. So I'm gonna scroll down and take a look at the example. Okay, so here's an example using a pandas series. Right now we have a pandas data frame. So I'm going to scroll down to the example that kind of matches what I have more. Okay, so here they have a data frame. So they just have a dummy data frame. It has two columns, A and B, and it's just a bunch of numbers. All right, so this is what it looks like. And then they're using data frame dot where, and then M, which is this expression, df mod 3. Well, mod is kind of like asking if it's divisible by, so wherever the data frame is divisible by 3. This actually says the remainder after dividing by 3 is equal to 0. So when we call df dot where, this is the result. I see. So where this is true, right, where it is divisible by 3, it is kind of applying the negative. Okay. That's not quite what we're looking for, though. We're trying to just find one column. So I'm going to look back at the series. It looks like if we just have some kind of condition, like we use our variable and we see it's a greater than, like something that will evaluate to like a true and false, right? So greater than or less than or equal to, those are all conditions that will evaluate to either true or false. Okay, But let's try doing that. I know, yes, documentation can indeed be difficult to read because it's so technical. Like it's very detailed, but it can be overly technical sometimes. Okay, so in the clean meteorites data frame, we want to look where our mass G column. So in order to get the mass G column, I'm going to use my data frame variable, clean meteorites, and get mass G. And I want to see where that mass is equal to, or maybe I'll do greater than or equal to, and then this number here, which was our maximum. Okay. So it turned every single row where this doesn't apply into nothing. Now I want to get rid of all these like null values. In order to do that, there is a function called drop NA in pandas. Drop NA. Okay. And after removing all those nan, which is NaN is like, that's not a number. Mm-hmm. And also just kind of means like null or nothing. So we drop all the invalid values. And now we are left with just that one really big meteorite, whose name is Hoba. It was in 1920, this latitude and longitude. And now maybe we're a bit more curious. Maybe we want to see like the top the top 10 largest ones. With this, I could technically just keep changing this number. I don't know, I'll change it from 60 million to like 50 million. Right, there's a couple more now that we see. But I'm gonna have to keep guessing the number. So instead of doing that, I'm gonna put it back to 60 million. We can also sort our data set. There's a function called sort. Again, let's go to the documentation page. I'm going to look for the sort function. See. Okay, the pandas search is not very good, so I'm just going to use Google. I search pandas sort. There we go. So we can use the sort values function on a data frame. And when we can sort by a specific column, we can even sort by multiple columns. So it's like if it's a tie and it has like the same exact mass, for example, we could like break the tie on the name in alphabetical order. Okay, let's try that. So we want to sort values by, we're interested in the mass. I'm gonna run this. All right, so it looks like the mass is starting from 0. So the mass seems to be in ascending order. But if we want the largest to be on top, we want this to be in kind of the opposite order, descending. So starting from the biggest and getting smaller. So if we go back to here, looks like we can specify ascending equals true or false in order to kind of flip the order. So in our case, let's set ascending equal to false. All right. Now we can see the largest on top. And you notice like there's some of these meteorites don't have a valid mass. You see all these NaN values. I guess that just means like they don't know how big it was. So it's a value that's not really available in the data set. We could do the same thing and drop all the invalid Na values. We call drop Na. Right now we see the zeros at the bottom. And also these are way too many meteorites. So we can't show all 38,000 of these meteorites. So if I wanted to see like the top 10, I think we can do head. Head shows us the top 5. If we want to see the top couple, I think, let's see. Yeah, so if we look at the head function, it returns the first n rows, where n is equal to 5 by default. So if I would like to see the top 10, I can do dot head 10, and that will show me the top 10 values. Right, so the huge difference between the biggest one and then like the fifth one already gets down to 26 million. Yep. Okay, well, this is very cool. Now we have this data and we probably want to like make a very nice looking graph or something out of this. So we could graph this in different ways depending on what you're interested in. Maybe do it by, we can have like the year on the x-axis, and then maybe we can have the mass on the y-axis. Maybe see, is there any correlation, right? Are the meteors getting bigger as the time goes on, right? Is the end of the world going to come, right? We're going to get like a huge one in the future. Maybe we're even interested in like, is there an association between like the latitude or the longitude and how big it is? Right.
Can only hope.
Kind of unanswered questions that we have. Like, why would you want to use pandas over it? It seems like everything we can do with pandas, we could like do in Excel or like spreadsheet, if you're already more comfortable with that. And that's very true. But what's nice about having things in like code, which is you can automate a lot of things. For example, you can like write a script that does a thing, like generate some sort of visualization, and you can have it like, you can load in any other data set and have just simply like press run and have all of that information like for multiple variants of a data set. You can also easily do more complex like interactions or even integrations with like other things. Maybe you have whenever you do like your research, you collect your data and like you upload it somewhere. You can have your, since pandas is also just like a Python script, you can have it like automatically run and do the data analysis like whenever you upload your data, for example. So just having it, the fact that it's in code makes it a lot nicer to integrate with other tools. Okay, yeah, just wanted to give that note before we keep going. Okay, so we left off, we have our clean data sets. We have been able to sort by values and see where our biggest ones are. And now I'm interested in graphing this and kind of showing this data set on an actual chart that I can see. So my goal here is I want to try plotting the year as well along with the mass on the y-axis. So one more time, I'm actually again not interested in the position right now. So I'm going to do similar thing we did earlier and drop these two drop these two columns from my data frame. So I'm going to make another variable. We'll call it mass and year. And I'm going to take my cleaned meteorites data frame and I'm going to drop I'm going to drop name. We'll drop rec lat. We'll drop rec long. And now if I look at my mass and year data frame, oops. Oh, I made the same mistake. So it says rec, these are not found in axis because drop by default has axis 0, which is on a row by row basis. Since I want to drop the columns, I have to specify axis equals 1, which is columns. Now when I drop it, I'm left with just mass and year. And now I want to plot this. So I can take my mass and year, and there's a very handy function called plot. So I could just do my data frame dot plot. And it generates this, but this is not exactly what I want. It looks like it's plotting both the mass and the year separately on the y-axis. I think it's using the index here, which is the numbering from 0 to the 0th up to the 45,000th row. And it's using that as the x-axis instead. That's not what I want. So we're going to look up the documentation for the plot function. See how we can fix that. So it's data frame dot plot, and we can have all these optional arguments. And oh man, there's a lot of parameters. Okay, so let's take a look at this. We can have data, x and y. So it looks like we can specify the x and the y. We can also change the kind of data plot, like a line plot or a bar plot, histogram. Right, so you can make your plot look very nice, adjust the size, add a title, all these things. I'm just going to scroll down to, they don't have an example. Okay, they don't have an example, so let's play around with this. So I'm going to try giving it an x and the y and go back and call plots. I'm going to say x is equal to, we want the x to be the year. And then let's try saying y is equal to the mass. Oh my. Right, so this is a line plot. And perhaps the line plot is not the best way to visualize this data. As you can see, it's all over the place. You probably want something more like a scatter plot. So I'm going to look back here. If you look at the kind, we can specify the kind of plot we want to produce. And we do have a scatter option. So I'm going to set my kind equal to scatter. Kind equals scatter. Okay, and now I don't have the crazy lines going everywhere. Okay. And so if we look at our data, we can see most meteorites are pretty small. You can see most of them are over here. I don't know if you can see my mouse, but yeah, most of them seem to be very close to the zero. We do got a few, that are all the way in like the 60 million range. There's like 3 there. Like, I don't know. It seems like as time went by, we started to see bigger and bigger meteorites. So let's say I want to kind of draw a trend line. Like I want to kind of be able to see, is this really getting bigger over time? Right? Would it be more like this, or would the trend line be more like this? Yeah, so we want to figure out a bit more on the statistics of this data. There is a very neat function that we can use on any data frame. So on my mass in your data frame, I can do dot describe. And it just gives us a summary of some of like the main statistics. So it looks like our mass mean, so like the average mass of the meteorite that we have is that's in scientific notation. That's 1.32 times 10 to the fourth. So that will be like about 1,300 grams. No, so 10,000 grams would be the mean. And then we can see our max is also here. Our max year is 2,100. That doesn't seem right. Maybe some kind of, maybe it meant to be 2011 or something, but they misinputted the data. But yeah, so we can see just a summary of the statistics. If you wanted to get like a very specific statistic, there is lots of other functions we can use. And I guess I wanted to kind of show everyone this. Oh yeah, Tanya put in the chat, maybe someone is predicting an impact. That's also true. For information like that, you would have to look at where you got the data from and see if they like describe like what's in the data. Okay. I found this nice cheat sheet that for like using pandas that I kind of wanted to share. So here's we use this in the very beginning, right? We use read CSV to load in the CSV file. I see dropping is also over here. Let's see. Let me draw. Yeah, so we have dropping tables over here. We did read CSV earlier. We also did sort, right? That's a common operation. So it's nice to have a reference like this because like chances are, even if you use this or unless you use this like for years and years every day of your life, you're not going to memorize all these functions. Okay, I'm bringing this up now because if you're interested in like getting more statistics, I guess it's in this summary section. So if you wanted to like find the median, for example, or say the mean, or like the total sum, you could use these functions. Now let's try the median one. So if I'm interested in I'm gonna erase my scribbles. So if I'm interested in just the median, since the median doesn't actually show up in this describe function. So it just tells me the median for each of my columns. So the median gram is actually only 32. Wow. So you can see like how skewed it is, right? Since the mean was like 13,000, but the median is only very, very tiny, 32 grams. Okay. So let's go back to our goal of, we have this nice plot. If we want to draw a trend line, well, when in doubt, always just look at your documentation. Let's see, we have I believe that there was some option. By the way, this also notice it says in the notes, see matplotlib documentation for more on this subject. So pandas is also using yet another library or code that other people wrote in order to do this visualization. So matplotlib is its own library that you could import and use even without pandas. But people also often, right, since you're working with data, they often use it together. So they have kind of integration with each other. For the trend line, let's just Google it. So I'm going to open a new tab. So we want to do pandas, trend line, add trend line to scatter plots. It's always a very good skill to learn how to read or learn how to solve problems just by Googling things. Okay. So they're using pandas. They draw the scatter plot. And then they're using a NumPy, which is another library, to generate a fitted line. Yeah, so they're all using like different libraries. We could use Seaborn as well. Okay. Let's use matplotlib. Okay, yeah, they're using NumPy. Okay, so let's go back here. So right now we did import pandas. So we have pandas in our loaded in our Jupyter notebook right now. I guess alongside pandas, so pandas is like dealing with the data frames, like large data sets and finding the statistics and such. There is another library called NumPy, which stands for like numbers in Python, which has like a lot of great tools for doing math related things. So let's see, if we import NumPy, we can see NumPy is this module. Looks like there is a NumPy function for fitting a x and y. Okay, so let us calculate a trend line. So we can use let's look at the documentation for this polyfit function. So polyfit NumPy. And NumPy has their own documentation. It looks quite similar to pandas, coincidentally. So it's from the polynomial API. I guess we're doing a polynomial fit on our data set with degree 1 since it's linear. We just have to give it the x data, our y data, and the degree, which since we're looking for a line, we'll use 1. do numpy.polyfit. For us, our x is going to come from our data frame. So we have mass and year, and from the mass and year, our year column. So here I'll do our x-axis is mass and year. Now we grab our year column. And for the y, we have mass and year, and we grab the mass column. And we have degree 1 since this is a line. Next, it wants us to call poly 1D. Let's figure out what that does. So it looks like polyfit will returns a vector of coefficients p with some math things. And then poly 1D looks like it's a convenience class. So I guess it transforms it into just a normal array. Or rather, it transforms an array of coefficients into kind of an equation. So it'll take the numbers 1, 2, 3, and turn it into a polynomial like 1x squared plus 2x plus 3. Okay, so I'm going to call this our coefficients, and I'm going to call this our polynomial. It's equal to numpy dot poly 1b with using our coefficients. Okay, and let's take a look at our polynomial. No. I got a math error. When I call numpy.polyfit, it's like they are not able to calculate the correct line for this. Okay, sorry for the technical difficulties. We'll skip on drawing the trend line, but yeah, that's one way you could plot. Now let's try plotting something else. So let's go back and look at our cleaned meteorites data frame. Let's see, maybe I want to plot the positions of the meteorites by, I could plot the latitude along with the longitude, and that way it'll kind of look like a map of where all the meteorites landed. Let's practice doing that. So first we want to clean the data so that we only have the columns that we're interested in. So let's have this be our lat and our long. We're going to take our cleaned meteorites data frame. We will drop the columns. We don't need name, mass, or year. Then we can take a look at our lat long data frame. Axis equals 1 for our columns. Okay, and now we can plot this. Do lat long dot plot. Again, if we plot it without any parameters, it's just going to want to plot each of our columns as its own thing. Since we want our latitude to be on the x-axis and our longitude to be on the y-axis, right? And of course, a line plot is not the best way to plot this. So we'll change this into a scatter. Type equals, no, it was kind equals scatter. Okay, well, that's interesting. So that's a scatter plot of all the locations of the meteorite. Now it'll be interesting to put this on an actual globe, but I don't think we have that feature. You would want to load this data set into like a, I don't know, Google Earth or something if you wanted to see the actual like geographical locations of all these. You see, it does follow some kind of pattern, which is interesting. Okay, I guess with that, yeah, there probably are like, each blob is probably like some kind of landmass or continent, since we probably would not see most of the meteorites that land in the water. Okay, I guess with this, does anyone have like a data set that they have or are interested at looking at together? Or maybe it doesn't have to be one that you have. You can just like search about a topic you're interested in, and we can try pulling in a new data set and take a look at it. If not, let's go look for one together. There is this website called kaggle.com, which is kind of like, it's like a community for a lot of like data scientists. But they have a lot of data sets or interesting data sets that we can download and play around with. So I guess if anyone sees one that looks interesting, just type it in the chat or call it out. We're just going to kind of browse and see. There's like a Starbucks nutrition facts. If you want to see what the worst drink is. Got exam scores, Walmart data analysis and forecasting. If you want to invest in real estate, you can analyze the real estate data. Yeah, we could also search for something in particular. Yeah, I remember people. There are people who did respond that they have like are doing research in genomics, so we could try practicing with that. Although I personally am not knowledgeable about genomics, so I might not know too much about how to analyze this. If we take a look at this, for example, see there's the dataset contains their RSID numbers, which chromosome that it is found in. So I wouldn't actually know how to, since I'm not a biologist, I would not know how to interpret this data. So sure, let's take a look at maybe weather data. Or maybe, I think water quality is a good one. So we can look at, let's try looking at this one. Okay, this is imaginary data of water quality in an urban environment. Let's try looking for world cities, air quality, and water pollution. So we have the name of a bunch of cities, the region or state that they're in, their country, and a number representing the air quality and water pollution. I'm not sure what the measurement is, like what kind of index you're doing. Let's see, so it says it varies from 0 being the worst to 100 being good. Pollution is 0 being good, because 0 is no pollution, and 100 to being extreme pollution. Sure, let's take a look at this one. So we can click download. So I can download the data that has been saved to my computer. Right, so now I have the CSV on my computer. Now I'll go through the same process to upload. Okay, it has a very long name. Just to make it easier for myself, I'm going to rename this file cities, air, water quality. Okay, and now I'm going to go back to my Jupyter notebook. First things first, I can always reference back my cheat sheet for this. We want to read in the CSV file. That's over here. I can use pandas.readCSV. Notice how they use PD instead of typing out pandas. A lot of people kind of use this way to shortcut or abbreviate since they use pandas so often. In order to do that, all you have to do is when we import pandas, we can give it an alias or like another name as PD. That way, when I load in the data, I can use PD dot read CSV, the name of my file. And I want to save it to a variable. I'll just call it data. So here's my data, which we did take a look at earlier. So we've got cities, New York. We've got the region, country, and just a number from 0 to 100 representing the air quality and water pollution. Wow, look at that. Spain has got some good air quality. So let's take a look, and there's some functions that we can use just to see. The info function is useful. It just gives you a kind of a summary of like the data types, how many entries we have, what are our columns. Right? I mean, nothing that we can't already see here. But let's see, what are we interested in? Maybe we want to look at, where are the cities that have the best air quality and what are the cities that have the best water pollution? We can use sort values in order to sort our data frame. We want to sort by a certain column. Remember that this is all on the cheat sheet. And look at the sort values. In this case, let's sort by air quality. So there's these double quotes that are around the name of the column. So it's a little annoying, but I have to match the name of the column exactly. So I'm going to use single quotes around double quotes air quality in order to match that exactly. Air quality. Okay, let's check the column names. So if we do data.columns, that will give us a list of all the column names. Oh, okay, that's annoying. When I look at the column names, air quality actually has this space character in front of it. That is a bit annoying. So maybe I want to rename the columns so that it's more consistent. Right? Because sometimes it's like this weird, you load in your data, but it's not formatted very, very well. Okay, so in order to rename a column, we can add the new column by doing data, and then I want to make a new column called air quality with no weird space or quotes after it. And I'm just going to set it equal to the weird looking data air quality. Now, when I look at data, now I have this extra column, duplicate column for air quality. But now that I have that there, I can drop the column. Axis equals 1 for column. And then when I look at my data again, okay, I already did the drop, so I can't do that again. Okay, so now I have air quality. It's not in weird quotes or anything. I probably want to do the same thing for water pollution. My water pollution has the same naming problem. So I'll just do the same thing, but instead for water pollution. So I'll make a new cell. I'm just going to use this cell. So first step is to create the new column with the name that you want. And then kind of copy the old one. And then you want to drop the old one. Okay, now when we look at our data, okay, air quality and water pollution doesn't have the weird stuff around it. Okay, now let's go back and let's sort our data. So we want to sort by air quality. Okay, so now we see all the air quality, it's in ascending order. Ascending means that we have the worst ones first. So, oh my, the city Yiwu in China has a 0 air quality. And surprisingly in Turkey and in Bloomfield Hills in Michigan. Right, so places, maybe some places that you would expect, maybe some unexpected places. They also have varying levels of water pollution. I mean, so the water in this region is like only 50% polluted. But man, what is going on in Bloomfield Hills, Michigan? All right, so we can only see part of the data since it's kind of cut off. But let's say we want to graph the air quality and water pollution. So we can do another scatter plot. Do data.plot. For our x-axis, let's say we use air quality as our x-axis. For our y-axis, we use water pollution. And chance, I would expect to see a correlation. Oh, whoops. We need to make sure we use a scatter plot. Kind equals scatter. This probably has to do with the nature of the data set. I see there's a lot of, it seems almost grid-like, where it seems like they just kind of rounded or estimated certain values. Like I see a lot of lines that are right along 50, right along 25, and right along 75. So we end up seeing this a bit of a grid pattern. I also see there is a slight correlation. Right, so generally the higher the water pollution, the higher the water pollution, the lower the air quality is, which is like kind of in our expected alignment. Okay. I guess if you wanted to make this plot look nicer, I mean you can use all the different parameters. I think we can adjust like the size. We can make this a little bigger, since this is a big plot. Okay, so that turned into a big square. Okay, so you can have it more spread out. I think with a scatter plot, we could, I think this is like a bit too many like points in order to like show each city name, but you could also do things like that too. Okay, not sure, what else could we explore with this data set? I guess there's not too much in here. Oh, maybe we can do it by country, see which country has like the most cities that are, the most percentage of cities are polluted. Okay. First, I'm gonna double check the columns. The country, all these names have this weird extra quotes and space problem. So I'm going to fix that real quick. Okay. So let's look at my data. All right, so I have country over here. And now this will be interesting. I want to kind of group all of my data by the country. And maybe I take the average air quality and average water pollution. But so I have a bunch of individual rows that have like a country. So how would I do this operation where I'm going to kind of mush down this table, combine everywhere where it says United States of America into one big row? Okay, I think first thing, let's clean our data first. The cleaning data means like delete everything that you don't need. So we're going to call this our country data. And from my original data, I'm going to drop the two columns I don't want, which is city and region. And then axis equals 1 because I'm dropping the columns. Okay. And then if I look at my country data, okay, so now we have just the air quality, water pollution, and the name of the country. Now I want to, there's a very handy function called group by in pandas because this kind of thing is common. So let's go look at the documentation for this group by function. Pandas group by. Okay. I would always scroll down to see, and to look at an example if it's available. Okay, so it looks like we call on our data frame dot group by. We give it the name of the column we want to group by. And then we want to specify how we're going to combine it together. So in their example data frame, they have like multiple animals. Maybe they've got like 10 falcons and 10 different parrots. And they all measure like how fast each falcon and how fast each parrot is. So it's very similar to us. We want to group by the country, and we'll also probably just take the average or the mean of the air quality. So let's try that. Country data dot group by. We are grouping by the country. And then we're going to combine, we're going to combine each row by taking the mean. Okay, very nice. Now we have, instead of 4,000 rows, we've got 177 rows instead, one for every country. And now these numbers represents the average. Okay, now to visualize this, let's graph it. So let's do another scatter plot. Well, this is a new data frame, so I'm going to call this my grouped data equals. And then we are going to use our grouped data and plot. We can do another scatter plot. X equals air quality, Y equals water pollution, and then find equals scatter. Make sure to run this cell. Okay, so we see much less points than before. And now each point represents the country's average air quality and water pollution. Okay, and now if I'm interested in actually like all the different countries, maybe we can make a bar plot. So with my group data, maybe on the x-axis, I want to see my actual country. And we can look at the air quality. And this will be a bar plot. Ooh, key air for country. Okay, let's check our group data columns. Oh, so our two columns are air quality and water pollution. Our country is now our index. Okay. Yeah, if you notice, it's like on two different lines. So normally our index is this like number, which just numbers them from 0 to 3,962 for each row. But once we group them, I guess the index is like the main, I guess it's like a unique value for every row. So now the unique value for every row is like based on the name of the country. Okay, so since the x-axis here is going to be the index, I'm just not going to specify it. Okay, Yep, and that's the air quality for every single country. Now we've got 177 countries, so all the text is like morphed together, which looks a bit scary. First thing we could do is we could just make this a bit bigger. A bit more visible, but it's probably not a good idea to display all 177 countries. Also, it's not, I mean, it just looks like pretty random. So maybe we want to, before we plot it, we want to also sort this as well as maybe cut this down to like the top 100 or so. Or maybe like top 30 or 20. So let's call this our air quality data. So I'm AQ data equals. First, we're going to take our grouped data and we'll sort values by the air quality. And then we also only want to include the top 100 or so, or actually 100 is a lot, top like 30 or so. So we can also look at our cheat sheet. If we want to select a subset of a data frame, we can just specify, we can use it almost like an array or a list, where we can just do bracket and then a number. And then the colon kind of represents like taking a slice of the list, which is like if you want to take, for example, from starting from index 2 up to index 10, then you can do 2:10. So let's do it. Let's take a slice of our AQ data. So first, I'm going to comment this. Let's look at our AQ data right now. It should just be sorted based on air quality, which it looks like it is. Let's take the top 100. So we'll do like from 0 up until 100. Yep, now it only has 100 rows. Or sorry, I keep saying 100. Let's take up to like 30. Yeah, so 0 to 30. Okay, now let's take this. I'm going to call this top 30. Or this is actually the worst 30, because the lower the air quality, the worse it is. Okay. That is a worst 30 air quality. And now I'm going to plot just this worst 30. And there we go. Now this is much more visible. It's a bit big, kind of hard to fit on my screen, so I'm going to make it a little smaller. And there we go. So we've got, okay. Is the lower air quality better or worse? To check this, air quality varies from 0 is bad to 100 is good. Okay. Yeah, so Central African Republic, I mean, this could either mean that like we don't have data, right? Because it seems like the average was 0, meaning like every single data point was 0. It could just mean we don't have any data for that area, or like, yeah, they literally have very, very bad air quality. Yeah, you see, so we have some African countries. We have China. Yeah, we got Madagascar, Kazakhstan. We got South American countries. Yep. And if we wanted to see the best 30, we could simply reverse the order of the way we sort. So if we sorted this, actually, like, let me make a new copy. Okay, so this will be like our best 30. When you sort, I'm going to say ascending equals false. So ascending means we start from small numbers and we get bigger and bigger. Descending means we start from the biggest number and get smaller and smaller. So this will be like the biggest numbers first. All right, and now we see best air quality. If you want 100% air quality, then you can go move to the Federated States of Micronesia.
Thank you so much, Trinity.